This video is on exponents, power of a power, and negative exponents. So a power of a power is when you have exponents that are all raised to a power that's on the outside. So anytime you have this, you're always going to look at the exponent on the outside and say, well, it's to the power of 3. So that means I'm going to do 2x to the 4th, y to the 3rd, times itself 3 times. Okay, and I can simplify this. I can multiply, well, 2 times 2 times 2 is 2 to the power of 3. And then remember there's multiplication in here. Anytime you have a number and a variable or variables right next to each other, they're always multiplied. So here I have x to the 4th times x to the 4th times x to the 4th. So when you're multiplying bases, you keep the base the same, and remember you add the exponents. So 4 plus 4 is 8, 8 plus 4 is 12, and then we have our y's. Y to the 3rd times y to the 3rd times y to the 3rd. So because we're multiplying the bases and the bases are the same, we're going to add the exponents. 3 plus 3 is 6, 6 plus 3 is 9. Okay, so now I'm going to show you a shortcut. So if you have a power raised to a power, you're going to take the exponents inside and you're just going to multiply them by the exponent on the outside. So even this number 2, it's raised to the power of 1. So any numbers or variables that do not have an exponent that are inside the parentheses, you're going to raise to the power of 1. So I'm going to keep the base the same, my base of 2, and I'm going to multiply the exponent times the outside exponent. So 1 times 3 is 3. Now I'm going to bring down x. 4 times 3 is 12. Bring down y. 3 times 3 is 9. So you can see we get the same answer. It's just a shortcut. We're multiplying all the exponents inside by the one on the outside. So let's try that again. Okay, so I have 4x to the 5th raised to the power of 2. So I'm going to raise the 4 to the power of 1, and I'm going to bring this down. I have 4 to the power of 1 times 2 is 2. X to the power of 5 times 2 is 10. I can leave it like this, or because 4 to the 2nd power is 16, that one's easy to multiply out. All right, again here. 3 needs to be raised to the power of 1. X needs to be raised to the power of 1. And y already has an exponent. So now that everything inside has an exponent, I'm going to multiply the exponents inside by the one on the outside. 3 to the power of 1 times 4 is 4. X to the power of 1 times 4 is 4. And y to the power of 2 times 2 is 8. Okay, so it's fairly simple. Go ahead and try these two problems. I'll go through the answers with you when you're ready. All right, this one, raised 2 to the power of 1. So we have 2 to the power of 1 times 3 is 3. X to the power of 9 times 3 is 27. All right, here I'm going to raise 7 to the power of 1 and y to the power of 1. So we have 7 to the power of 1 times 2 is 2. X to the power of 4 times 2 is 8. And y to the power of 1 times 2 is 2. Hopefully you got those answers. Now we're going to move on to something called zero power. So anything raised to the power of 0 equals the number of 1. So 9 to the power of 0 equals 1. X to the power of 0 equals 1. 2x squared all raised to the power of 0 equals the number 1. All right, so I'm going to give you a little example of why this works. So if I have bases that are the same and I'm dividing, I can just subtract the exponents. So this is 3 to the power of 4 minus 4, because when you're dividing bases, you subtract the exponents, top minus the bottom. Well, this gives us 3 to the power of 4 minus 4 is 0. Okay, so I know it's 3 to the power of 0, but let's look at why this will equal 1. 3 to the power of 4 is 3 times itself 4 times. over 3 to the power of 4 is 3 times itself 4 times. Okay, when you are dividing anything by itself, it equals the number 1. So 3 divided by 3 is 1. 3 divided by 3 is 1. 3 divided by 3 is 1. And 3 divided by 3 is 1. So this is basically 1 times 1 times 1 times 1. Well, when you multiply 1 times itself, 1 times 1 is 1, 1 times 1 is 1, and 1 times 1 is 1. So that means, because these are the exact same ways, they're the exact same thing, just different ways of doing it, they both will equal to the number 1. All right, now we're going to look at something called negative exponents. So if there is a negative exponent, like x to the power of negative 2, the reciprocal, or flip it over, will make the exponent positive. So 1 over x to the positive second power. All right, so on this one, if I have 3 times x to the negative fifth power, 3 doesn't have a negative exponent, so 3 stays at where it's at. The x to the negative fifth, you're going to flip it over, or it's going to go to the other side of the fraction bar, x to the positive fifth. When it's flipped over, just the part with the negative exponent, or move to the other side of the fraction bar, it will make the exponent positive. All right, this one, y is the only thing with the negative exponent. So that's the only thing that I need to find the reciprocal of, or flip it over to the other side of the fraction bar. So 4x squared stays on top, and y to the positive third goes on bottom. Okay, so here, this time I have a negative exponent in the bottom. To move it, to make the exponent positive, that's going to move to the top. Flip it over, or move it to the other side of the fraction bar. So this is positive 2x to the positive fourth. Okay, so we're going to simplify. You're going to write your answer using only positive exponents. So here we have 3 times 2 is 6, and we're multiplying the bases of x. And remember, when you multiply bases, you add the exponents. So this would be 2 plus negative 3. Gives us 6x to the power of negative 1. 2 plus negative 3 is negative 1. But I want this exponent to be positive. So this part has to move to the other side of the fraction bar. So I'm going to put 6 on top, put a fraction bar below it, and x to the positive first, or just x, goes to the bottom. All right, this one I have to do one step first. I have a power to a power. I'm going to raise 3 to the power of 1, and I'm going to multiply all the exponents inside by the 1 on the outside. So 1 times negative 2 is negative 2. X to the power of 2 times negative 2 is negative 4. So everything has a negative exponent, meaning it all has to move to the other side of the fraction bar. So 3 to the positive second, x to the positive fourth. But I need to have something on top. That would be 1, because when you flip it over, 1 would be on top. Remember, to make this into a fraction, I can put a 1 below it. So when I flip it over, the 1 would be on top. And I can even multiply this out if I want. 3 squared is 9. X to the fourth. All right, so let's try a couple where division's involved. So remember, when you're dividing bases that are the same, you're going to subtract the exponents. So this will be x to the power of 2 minus 7. I'm just going to write it out, and then I'll deal with it in a minute. Y to the power of negative 3 minus negative 5. It's always top minus the bottom. Z to the power of 4 minus negative 1. Okay, so now I'm going to simplify. This equals x to the power of 2 minus 7 is negative 5. Y to the power of, I have minus and negative, so I'm going to change it to plus the positive. Negative 3 plus 5 is 2. And z to the power of, change minus and negative to plus the positive, 4 plus 1 is 5. Okay, the only part with a negative exponent is my x, so that's going to move to the other side of my fraction bar. It goes down. So this gives me y squared z to the power of 5 over x to the power of positive 5. Okay, same thing here. All right, I have 5 over 10. Well, 5 can't be divided into 10 evenly, but I can reduce it to 1/2. Okay, now I'm going to do everything on top. Remember, m is to the power of 1. I'm going to deal with m, and I'm going to do top minus bottom. So 1 minus 4. Then I have n, negative 3 minus negative 3. Now p. 0 minus 2. Okay, this gives me, well, if I have 1 times m, I don't really need that 1 there. Okay, so I have m to the power of 1 minus 4 is negative 3. N to the power of, well, minus a negative changes to plus a positive. Negative 3 plus 3 is 0. And p to the power of 0 minus 2 is negative 2, all over 2. Okay, I need to make this exponent positive and this one, so they're going to move to the other side. So that means on bottom, I have the 2 on bottom, m to the positive third when it moves down, and p to the positive second when it moves down. But n to the power of 0, anything to raise to the power of 0 equals 1. So there's just 1 on top. Okay, so I'm going to have you try 4 problems similar to those. Then I'll go through the answers with you when you're ready. All right, this is raised to the power of negative 1. So we have 5 to the power of 1 times negative 1 is negative 1. X to the power of 3 times negative 1 is negative 3. So everything has to go to the other side of the fraction bar. Remember, just flip it over. So this is 1 over 5 to the first is just 5, x to the positive third. Here we have x to the 4 minus 3, y to the negative 1 minus negative 4, and z to the second minus 7. I'm going to change this minus and negative to plus a positive. So this gives us x to the power of 4 minus 3 is 1, and x to the power of 1 is just x. Y to the power of negative 1 plus 4 is 3, and z to the power of 2 minus 7 is negative 5. So just my z has to go to the other side of the fraction bar. So x times y to the third over z to the positive fifth. Okay, and number 5. We have x to the power of 0 minus 2, y to the power of negative 2 minus negative 1, and z to the power of 5 minus 7. I'm going to change minus and negative to plus a positive. So this gives me x to the power of negative 2, 0 minus 2 is negative 2, y to the power of negative 1, negative 2 plus 1 is negative 1, z to the power of negative 2. Because everything has a negative exponent, all has to go to the other side of the fraction bar. That means 1's on top over x squared, y to the first or just y, z squared. Don't forget when you move it to the other side, it becomes positive, the exponent, just the exponent positive. All right, this I can reduce. 16 divided by 4 is 4. M to the power of 3 minus 5. N to the power of 2 minus negative 2, p to the power of negative 6 minus, this p is to the power of 1, so negative 6 minus 1. So 4m to the negative second, 3 minus 5, n to the power of, change minus and negative to plus a positive, 2 plus 2 is 4, and p to the power of negative 7. Negative 6 minus 1 is negative 7. So I need to move this part and this part to the other side of the fraction bar to make my exponents positive. So I'm going to leave the rest on top. So 4 into the fourth over m to the positive second, p to the positive seventh.